learn about the good stuff. Yeah. Enjoy, everyone. Have fun.
Thanks. Thanks so much. So thanks for being for the space. Raise a hands who's here for marketing primarily? Yeah? Who's from machine learning / data science? That's pretty even split. Okay, cool. We're going to talk about both. So we're Indico. If you want to follow us, you can get Indico Data at Indico Data on Twitter. Me personally is DJ Kuster. I just started using Twitter. Not kidding. I came from the machine learning side, as you can tell. So we're going to talk about machine learning. Number one, what is it? How do we do it? Then digital marketing, what is it? How do we use it? And then how does it actually work to use machine learning plus digital marketing? We want to automate stuff so that we can get some real good impact out of this. And then I imagine this is probably what people are really here for. What are some real world examples of how this stuff works and how it returns value to people, why bother? Sound good?
Yes.
Okay, so what is machine learning? Don's going to help us along. Okay, so this is machine learning in a nutshell. So this is kind of, if you want to wrap your brain, if you're a digital marketing person, think about the purple stuff. If you're a machine learning person, this maybe will add some color for you. So we start with a problem. We say, okay, what data do we need to solve our problem? Right? Maybe we're looking at text, right? Say, okay, we have to take that data and put it in some kind of a representation that the machine can understand, right? So if you're doing something like text, that's because it's a language. You have a language as a vocabulary. We're going to take the text and we're going to say, this word is this word from the vocabulary, and we're going to give it a number, right? All these tokens. We're going to take these tokens and we're going to make a sequence of them, which is just like your sentence, only this is something that a machine can have, right? We take these features and we're going to count it, and we get frequencies, okay? We feed that into a model, in this case, something like logistic regression, and we end up with something that says there's a probability of this thing being a positive tweet or a negative tweet, right? So just to kind of go over that again, so machine learning in a nutshell. We have a problem tells us what data we want to use, or vice versa. We use a data to create a representation the machine understands. From that representation, we create features that we're going to use to feed into a model. And then from the model, it makes predictions. We use the predictions to inform what we want to do and feed it into the pattern. Yeah? Okay, sweet. Okay, so what's digital marketing? Digital marketing is what Don does plus data, right? The cool thing about this is we have data now, so we can do all kinds of neat things with that. Specifically, what are the different things that kind of fall under the digital marketing umbrella? You guys who do digital marketing, awesome, why not you happy ones? So mobile apps, this would be things like that app store and you see ads pop up. SMS and text messaging, I think this is particularly cool if we start talking about things like chatbots. Can you hear me okay? E-commerce, things that you have bought in the past, maybe you want to recommend things you want to buy in the future. Email, want to do an email marketing campaign to attract users, figure out what your user base is doing. Video, like things for YouTube, etc. Content, so websites, social media, Twitter, Facebook, Instagram, Snapchat, etc. Search ads, which is probably what a lot of people think of when they think of digital marketing. One of the many things, one of the big channels in the umbrella. And other things like, I also think Slack is pretty cool. So other kind of channels where you're, different kind of user interaction with them. So these are all channels. Because there's so many channels and there's so many things that can generate data and give you things you can optimize on, sometimes it's actually more useful to think, what is it digital marketing? And these are basically things where you broadcast it and get nothing back, right? So you can think about, Super Bowl ads in classic TV, radio kind of sense. Anytime you ship somebody a desk, etc., right? Things that cannot respond to you, that can't generate any kind of data artifact, data asset. Okay, so Don's really happy because we have lots of channels and lots of data. This means good business for Don. So, question for you all. What year did the dollars spent on display ads surpass the dollars spent on search ads? 2000? Nope.
2013.
Nope. Whoever gets it right gets the next one.
It
Nope.
Ever?
Close.
2015.
Close enough. It's 2016. So the curve just crossed. So this year is the first year when you actually have display ads surpassing search. This is actually really cool because display ads include a native kind of image component. So we're getting a lot more kind of rich content that we can look at and analyze for stuff. Okay. Machine learning, in a nutshell, we're good. Digital marketing, in an umbrella, we're good. Right? So how does it actually work? How do we use machine learning to automate digital marketing? we've got data, we're going to automate it, but why bother? And I think it's really important to actually take a step back at the beginning and say, is this something we should even bother doing, automating things using machine learning? Say, okay, well, what are the benefits, right? One of the clear benefits is you can scale this. Because it's a machine doing it, you can replicate that across the cluster, across the cloud, whatever you want to do. And this can actually give you a lot more kind of, evaluations per time than you could probably hire people to do. If you're going to hire that many people to do this, it's going to cost you a lot. As well as it takes time for a person to read something or to look at an image or whatever. Sometimes a person's faster than a machine, sometimes a machine's faster than a human, right? So you can also have this kind of problem of latency. How do I actually ship that content to a person, have them evaluate it, analyze it, get that output, take it back and do something with it? It can take a while. Like, you can think about mechanical turking it. Maybe you can get down to like a few seconds, like best case scenario. That's still pretty slow for some kind of problems. You're not going to be able to bid on an ad in real time using a human in the loop, right? And then complexity. And I think this is something that's often, people forget about, but it's another kind of cost and it's very real. If you want to manage a process to do this kind of stuff, like you don't really want to get bogged down in details, right? You want to have something that works. You want to think about, your thing in a nutshell. Move on to solving bigger and better problems, right? Do what you do best. Okay, so when we think about data, this is probably what's going to be the kind of framework for the rest of the talk. So we have two ways we can do digital marketing, more or less, right? We've got demographics-based digital marketing. Who is this person who is consuming whatever? Who are you trying to market to? How do you segment them? What are the demographics, right? Who are they connected to? So this would be like, the classic metadata, or who are their friends? What do they like, what do their friends like? Who are the influencers in this niche? What are they browsing, previously, et cetera. So this is what has been going on for the last few years. The trend that we're seeing emerging now is actually really interesting. And it's not so much what are the demographics of the segment, it's more what's this person saying, right? So there's content that people are generating, and generating it in a way, we want people to consume what we write. We want people to see our tweets and react to them. We want to engage. So we start thinking specifically about things like images and text. Yeah? Is this resonating? Yeah? Okay, cool. How many of you guys are doing this kind of thing? Yeah? Really? That's it? Yeah? Okay. And anybody doing this kind of stuff? Yeah? Awesome. Cool. Okay, so on the first one, how do we do a demographic targeted digital marketing campaign? Let's say that we want to do something with Facebook. Facebook has an API. We can use this API in order to be able to slice that kind of demographics and market specifically who we want to. So if you do this, it's just under docs, right? So you can use things like user location plus someone who RSVP'd to an event plus has relationships with other people on their graph, right? That starts to get a little bit creepy to me. I don't know. But like, I've used Facebook in a long time actually, but I didn't know that like all this information was available. It lives on a server somewhere. You have no way of knowing when it's actually captured. I think a lot of the things you probably can have fine-grained control over through Facebook, but there's no way you can control what other people in your network are doing, which ends up revealing a lot of information about you. So Facebook has awesome user data, right? This kind of thing is not available through like Twitter, for example. We'll do one with Twitter later. Okay, so this is basically how it would look if you want to be able to target people. So green is the color we're using for digital marketing. Purple is what we're using for data machine learning stuff, right? So if you want to be able to target people and serve content to a specific demographic of whatever the hypothesis here being, if you can specifically target people who are like the kind of people that you want to have an outcome for, right, or that you want to engage, then you can optimize your spend to only reach the people who are going to respond anyway, right? So there's a lot of pros and a lot of cons to this kind of thing. The real pro here is that Facebook has done a heck of a lot of work and gathered a lot of data to make this kind of thing possible, right? It's a really nice interface. They have an API, it works. Facebook is doing well because of this. And also it can be actually pretty cost efficient compared to, kind of traditional non-digital marketing, or even compared to other channels, right? So I wouldn't be surprised if we're going to see some real interplay here between this and search ads. And we're going to see, in the next, year, as cons, Facebook has control of this, and you don't necessarily see what the different kind of dynamics are that are interacting there. So you get what they give you. As well as who you know is probably something that happens after you've already made decisions or acted in the real world or had some interaction with people. So because of this, that is like, if there's a lag between when the thing happens in the real world and when you see that show up in the Facebook graph, right? For me personally, it's a little unsettling when you have, stuff that you weren't necessarily aware was out there, maybe could be revealed and marked for marketing, etc. As well as this is I think the real clincher here that's interesting from a content-driven perspective is your interest can change very quickly, right? So for example, in the past year, our family bought a house. So when I'm searching for a house, you see ads for all kinds of things. Turns out that people love buying ads for homeowners insurance, right? Very valuable keyword. But after you buy a house and after you get homeowners insurance, you don't need another house. You don't need more homeowners insurance, but it still shows me these ads, right? They're really expensive ads, so sometimes I click on it. But I'm always not going to like do it, right? On the other hand, if it knows that I'm going to do this kind of stuff, you might actually say like, hey, you've had a house for a few months now. Maybe you actually want to like find a plumber, fix the toilet, kind of stuff. But this gets really difficult to tease out, right? Okay, so let's focus it in a little bit. We have the machine learning in a nutshell. What does this actually mean kind of in the context here? So let's say that our data now are content, and we want to be able to look at content that people are engaging with in order to find people who like that kind of thing that they're talking about. Our representation is going to be a feature vector. At Indico, we think of image and text data in terms of feature vectors. We have an API that you can actually digest these feature vectors on your own if you want. It's very low level, but for the data scientists and machine learning people in the crowd, you should totally check this out. It's a really great way to get started and do experiments very quickly. Yep. So what is a feature vector? Remember when I had machine learning in a nutshell before, and there was a number, comma, number feature vector. It could be all kinds of stuff. So here, we'll come back to it. Is that, yeah? If I don't make it clear, just bug me. Yeah. Okay, so maybe the like more underlying thing is what is a feature, right? So a feature depends on what kind of model you want to build. If we're building neural networks, the way neural networks work is you are looking at the thing and you're looking at pieces of the thing and trying to figure out how do these pieces compose together to let me understand the thing, right? So you can imagine what are the pieces of a dog, right? Pieces of a dog, it has a head, it has eyes, it has hair, it has a tail, maybe, right? But like all those different pieces can be quite different. You can have a Great Dane or you can have a Dachshund. They both have hair, but they're very different sizes, different sizes heads, different size heads, etc., different colors. And so what we're going to do is we're going to let the model decide on the things like how big is the dog. Like, we don't really care how big the dog is if we're just looking for a dog, right? But things like hair, dogs have to have hair because mammals have hair and dogs are mammals, right? So that's a really strong feature. When we say a feature vector, these are informative pieces of things like what's the hair look like to the model would be a feature, right? And the model, because of the way we train these things, these are deep neural networks, it learns to figure out its own features as it progresses through. Is that helpful? So yeah, this is a good question. So the old way to do machine learning a few years ago, before kind of neural networks and deep learning came on the scene, is you would have to have some expertise about what is a dog, right? And then you would say dogs have hair. You say, how do I make a filter in this image processing pipeline that detects hair? And you would do that, and you get features for is there hair in this patch of the image, right? And then you would feed that into your model. Now you have to figure out, okay, what's another feature of dog? Dogs have heads. Okay, so like, how do I detect heads? You're like, oh crap, it's hard to detect heads. Right? Maybe you're like, it's kind of circular. Then you're like, well, what if only half the head has light on it? There's shadow on the other half. Like, oh, well, I guess I need a shadow detector and a head detector, and they have to work together. And this kind of interaction gets really brutal. So even for something like, is it a dog, which humans can do really well, being able to encode all the things that we decide about when we're deciding is this a dog, turns out to be really difficult, right? Yeah. So that's the part that gets rolled into the model here. If you do a good job of your representation, then you can kind of enumerate all the features that are interesting, and then the model decides how to weight these so that you can make a prediction that is what you want it to do. Great. Do all kinds of things. So remember when I said there's a problem up here, right? Your problem and your data together decide kind of how you're going to process it. You can decide what your output's going to be, right? So if you want to do some kind of a search problem, like I want to find users, or I want to find words, or I want to find whatever, right? We can actually think about, there's also really a similarity problem. So instead of saying I want to find, dogs, you could say I want to rank this list according to how dog-like everything is. You sort the list on dog-like output, and now we have a search function, right? Sentiment would be, like how positive or negative is this thing. It's a pretty straightforward use case. We can talk more about that if you want. And then we can do things like emotion or many other things too. Okay, so use cases. So for an example, sentiment analysis is maybe the simplest kind of possible machine learning model. You're literally saying, is this positive or is it negative? There's only two possibilities. We're going to give a probability positive and a probability to negative. Those probabilities have to add up to 1. Okay? So how would you do this in general, right? You would go through, if I was going to do this, enroll it from scratch. Say that you're the only machine learning person or data scientist at your company. You want to be able to make something that says this, person talking about things in a positive way or negative way in this tweet, right? Grab a bunch of tweets, okay? From all these tweets, you label them as positive or negative. Your content here is going to be text. Your feature vector, we're going to say we have all these words. We're going to take the words. We're going to count out all the unique words. For every unique word, we're going to create a vocabulary. And then we're going to say, we're going to sort them in order, so the most common words are at the top, and the least common words are at the bottom. And then we're going to take text and match it to the word that it is, give it a token ID. So the word the is very common. It might get a token ID of like, 8 or something. The word butterfly, not very common. So it might get a token ID of like, 30,000, right? And we get all these, top to bottom, most common token IDs on things. Those are our representation. We're going to go through our tweet or our document, and we're going to do this analysis, right? We're going to take the text, we're going to get the token IDs. For all the token IDs, we're going to scan through and count how often it occurs in the document, and then we're going to divide it by the total number of words in that document, right? So we end up getting this kind of like normalized frequency of words in the document. Follow me so far? Okay, this is like classic kind of natural language processing way to solve this. Our model at this point really doesn't matter because our features only have a certain amount of information in them for stuff. But you could use like an SVM, a support vector machine. You could use logistic regression. But really what you're trying to say is you're trying to say how important are each of these counts in terms of deciding if it's a positive or negative tweet, right? I wrote the slide for our OAB neural nets. But if we're doing this logistic regression one, then we go from here, we make predictions, and each prediction would have a probability with it. So you get a probability of them being 0 or 1. You're going to set your threshold for what you're calling positive or negative, depending upon whatever your use case or your business need is. If you want to be really conservative, you might set really strict thresholds. If you really, just want to show everything, you might use 0.5. Right?
So the first step has to be human-driven, right? To create the data set that you can use to train a model.
Yep.
Right. So it's a human saying this is positive, this is negative, this is positive, and then how well do models typically account for things like sarcasm or double negatives and stuff like that?
Perfect. I was waiting for someone to ask. Okay, so there's 2 ways to do this. Way number 1 is like we just talked through, you're going to roll your own. You're going to go gather 1 million tweets. You're going to analyze all those tweets and say if they're positive or negative. Whether you do it or you hire a bunch of people to do it, you have to have a human kind of encode that judgment somehow. The other way you could do it is you could also fire up Indico or some other API that does sentiment analysis, right? We've basically already done this work for you. We look at gazillions of things that are already labeled, and we encode good features, and we feed those into a good model, and we do good evaluations to figure out that we're not doing this kind of like bias before after the movie kind of thing. And you can go on and decode it and see that one. But basically there's an API, and a website just wraps this API. So if you guys want to play with it, you can grab it. There's free, you get 10,000 free calls per month if you want to do it on your own. So you should totally do that. But ultimately what I'm trying to get across is that the problem isn't hard. The implementation of it gets kind of messy, but there's no reason you need to think about the digital marketing plus machine learning thing as being any more difficult, right? Data in, walnut, data out, right? Where your data in are all your texts, and your data out is some kind of prediction, right? So Indico is so easy to use. Exclamation mark, really positive, really positive. There are other examples here you can play with, or you can just type in your own. Things like Indico is so not easy to use, right? This actually gets hard because the not is very kind of several words apart from the thing that it's talking about. So you want a model that actually doesn't just look for a not thing. It looks kind of back in the sequence and figures out what to do. Our model should work for that. Yeah. Does that help? That was
Yeah. So I imagine it gets very complicated very quickly. It's about proximity to other words and keywords.
Yeah. So all these questions are kind of like thinking kind of how you would do it. I would encourage you to think about what problem you're trying to solve and like what you want in and out, and like that chunk in the middle. Start off just like doing something that works, and then when it doesn't work well enough, you iterate and like get more complicated.
Right.
You know what I mean?
Yeah.
So like this whole thing of like assuming we know what we want the model to do and kind of hand engineering it in. This is totally how people did it a few years ago, kind of before the deep learning stuff came into play. Nowadays, it's like we just can't optimize as well. We're talking like millions of parameters in this stuff, and there's no way that any of us can like juggle a million things, right? So, yeah. For the folks like Colleen in the room, who does like front end, design, design marketing, etc. This is how you do it. So, one line of code. Actually, I guess it's one line of code. You import the library. This is Python. You define your API key, and then you have a single example, which is the thing, and I want to pull in and analyze this sentiment, or you can do it in batch. That's it. Okay? So this is the way you should think about the problem. Regardless of what API you want to use for stuff, this is how you do it, right? Okay, next example, not sentiment analysis anymore. What if we want to look at a chunk of text, and we want to say, the person who wrote this text, what emotions were they trying to convey to me, right? So now instead of saying positive or negative, we have 4 categories. So we're going to look at things like anger, joy, fear, sadness, and surprise. You can see on this one, like seriously, my life is bleak, I'm unemployed, depressed, and I suffer from severe anxiety, right? Is this person angry? Like, not really, you know, but maybe there's some fear, you know, included in this, and definitely sadness, right? So really, really sad kind of stuff. So you can do the same kind of thing. You get a percentage for each of these 4 categories, or 5 categories. Yeah? Cool. What if we want to say, I'm not so interested in the emotion the person's trying to express in the text. I'm trying to see who's the person that wrote that. Like, what's some kind of like, you know, personality level characteristics about that person. So you guys may or may not be familiar with Myers-Briggs type indicator. This is a similar kind of thing, right? So if we take the entry on Wikipedia that describes gradient descent, which is one of these methods we use to train neural nets, it's kind of dry if you don't like that kind of thing. So gradient descent is a first order optimization algorithm, what are the personality types that are most likely to have written that chunk of text? And you find Myers-Briggs types that are, you know, associated with like, you know, I and T and things like this, right? Cool. Okay, another thing that might be really interesting is this idea of persuasion marketing. So how do you convince somebody that your product is awesome, right? Maybe you can find people that that person trusts, which we would call maybe influencers, right? So the things that other people are consuming and that they really trust, like in a specific niche. I really like wearable devices. If you guys use wearable devices for exercise, you know about this website, which is DC Rainmaker, right? Yeah? No? Nobody? Okay, I'm the dirty sort of. Okay, anyway, this guy reviews like everything in like Garmin and Apple and like anybody else who makes these devices. They want to send their stuff to him because they know that he's going to do a really thorough test of it, he's going to write it up, and that people are going to buy that product, right? So this is this idea of persuasion marketing. There's a customer of ours, Maverick, that wants to do this kind of thing as well. So influencer analysis, be able to reach out to people who are influencers in a particular niche and find things that those people are talking about and be able to do campaigns with them, right? How does Maverick figure out what everybody on the internet is saying and figure out who the influencers are, right? And you can figure out there, or you can quickly kind of peel back the layers here and realize, well, maybe they have like a sentiment analysis kind of thing they're doing, right? Or they have to have some idea of, this person was talking positively about this product, and this product is about, you know, triathlons, right, or sports kind of thing. And so you can kind of start thinking about the ways that you would do this. Yeah? So they do Facebook campaigns, is how they do it. Yeah? This one's kind of cool. So say that you want to grow your audience of followers on Twitter, right? You can do this manually. There are services like all over the place that do this through hacks like, you know, follow a bunch of people. Some of them will follow you back, you know, kind of thing. But what if you actually want to say, we want to understand who are the people who are out there who might really like the kind of stuff that we're about. And we want to reach them and say, hey, you might really like our stuff, check it out. How would we do that? You could run a Twitter engagement campaign, right? So if you run a Twitter engagement campaign, you can do things like, I want to find people who are interested in Facebook, right? And then you assign a budget, etc., and they market this and put it as an interstitial ad when you actually use Twitter. Right? So there's some chance that if you like baseball and talk about baseball stuff and are categorized in their system as baseball person, that you will see this ad, right? So the whole point of doing this is kind of small, I apologize, but you have impressions, which is basically how many chances that a person, I mean you guys know this, but like for folks who don't, how many chances does the person have to see your content, right? So you have these impressions, that's kind of the top of your funnel that you're optimizing, and then you get engagement, and ultimately what you're tracking is conversion. You want to know how many people actually made it all the way through, clicked on the thing, and came to you, right?
Sorry, quick question. What program were you using to have all of that engagement? The API that you had showed before?
That's just Twitter.
Oh, okay.
Yeah. So if you just Google for a Twitter engagement campaign,
Okay.
it'll bring you up there, and you can just create your stuff and put it in.
Awesome. Thank you.
Yeah. Okay, so that was, remember we had the two kind of main thrusts. You can market to people by segmenting on demographics, or you can market to people based on what they're saying, right? What if, I just described the way you can do it through demographics, this way, right? What if we wanted to also do that from what they're saying? Right? So we actually did this experiment, it's kind of cool. So this is, you should eat your own dog food. This is the classic example. So this is Indico's Twitter page. You actually should check this out, it's really cool. And we want to find new followers who talk about things that our current followers talk about, right? They express kind of the same interests, tweet about similar stuff, etc. Right? So how would we do that, right? We did a little experiment where we compared what I said, the first one, the Twitter user segmentation, versus we're going to analyze the text that's in these tweets that people are talking about, and we're going to call that our user content, and we're going to put them head to head and see how much conversion we get from one channel or from one kind of method versus the other method, right? Now, so the way that we do this is we actually take a bunch of users that are candidate users, and then we filter it through our own stuff, and we feed that into Twitter as a custom list of users we'd like to reach, right? And our engagement's awesome. So like you compare the two, and I think this is like 0.08%, and this is like rescaled axis on me, I'm sorry about that. And this is like, 4 times bigger than that. So this is pretty cool. There's pros and cons to this, right? One pro for Twitter is they have massive reach, and if you're segmenting on demographics, everybody has all the demographic information available. If you want to reach everybody who really loves the Boston Red Sox and talk about, I don't know, triathlons and stuff, that might be a really small intersection. So even if you have a perfect way of finding those people, you can't create new people, right? So you still have this kind of like, scale versus reach kind of thing going on.
Sorry, can you say again what is your model for content? Do you filter people
Sure.
who have positive emotions or?
Yeah, thank you. I totally skipped that. Yeah, so when you tweet something, there's text. So we take all those tweets of all these different people, and we feed it into a model that runs on our text features API, right? So our text features API is basically something we've trained on this deep neural network to figure out what things are really important in terms of like topics, sentiment, and all kinds of things that people use English for, right? And we're spitting out these features, and then we use that in order to look for things that are highly similar between our user base and between people that are not in our user base but maybe should be, right? And when the similarity is really high, we put them on a list, right? And most people, the similarity is not high, so they don't go on a list. We take that list and we give it to Twitter, and we do this engagement campaign with our custom list, and then we track the same exact way downstream of there. Yeah? So that's pretty cool. I mean, it's an experiment. We'll see how it goes, but pretty cool stuff. Talked a lot about text. What can we do with images? There's a really cool kind of growing trend right now for I want to look not just the whole image, I want to look inside of an image, and I want to find things that are going on in that image and specifically pull them out, and then do something with it. So there are certain things that are really strong in this image. Like I see a vineyard, I see a bottle of wine, I see 2 people, maybe a forest in the background, I don't know, and definitely glasses of wine. So if what we're looking for is glasses of wine, we can train a neural net to actually go look for specifically glasses of wine, and then find all the images that we find on social media, whatever channel you're trying to market to, that has glasses of wine. Now, it doesn't care if the glass of wine is going to be in front of the vineyard or not. It doesn't care if it's 2 people or whatever, right? We're looking for glasses of wine. You can imagine this being a pretty powerful way to grab users and whatever, because in the marketing world, you're looking for intent. So people who post pictures, people love posting pictures of things for some reason. So whatever the drink is, coffee, wine, water, whatever. So you can send a campaign to people who have a certain intent, and you can detect that intent by looking at the content of the image. So, you guys want to know how it works, or should we blast through? Yeah.
So how does somebody know what the how does it know what the content of the image is?
Okay, that's perfect. Yeah, so let's dive in. I'm going to spend 3 minutes going through how this actually works and how it knows. And if it's too high level, I'll dive deeper. And if it's too in the weeds, you know, like wave your hand or something and all the rest. So it's pretty cool. So this is the machine learning kind of landscape. This is a type of model called the convolutional neural network. The way a convolutional neural network works is, everybody familiar with Photoshop? Yeah? In Photoshop you have like Gaussian blur. You ever wonder how that works? Yep. So the way it works is you actually apply a convolutional kernel, you slide it across your image, right? And you get some kind of a blurring result. What that convolutional kernel is doing is it's looking at the pixels at every value and the pixels that are next to it, and then it's doing some math to make the result. So instead of blurring, you could also do things like just figure out what's there, right? Remember that. So that's basically what this is doing. You have an array of numbers, which is your pixels in the image, and they're stacked up into an array, right? We take these and we encode them. Here's like 1, 2, 3, but it could be anything. It could be black and white, it could be color. We take our input image. We do many different types of convolutional filters, like in Photoshop. Like imagine you just spent, 30 years sitting in front of Photoshop developing the perfect custom filters to detect wine glasses. That's basically what we're doing in a few seconds, right? And so you get these, you stack them together, and then you say which ones are active right now. As I look at this particular image, you might say filter numbers 1, 4, and 300 are showing something interesting. And you pass that downstream to something that makes a decision on those and does more convolutions. And this is why it's deep. It's because you have convolutions on convolutions all the way down. At the final layer, we're going to say, okay, now I've got some representation of what's going on. So each level we have representation. The last one is telling you the most about what's in the image. Right? So you want to be able to take that and pass it to something that makes a decision. Is there a wine glass here? Right? And so that we're all the way through here, and we're at this last thing. Each little dot would be for what kind of thing could be in it. So you would have a bunch of things that say, not a wine glass, not a wine glass, not a wine glass. Ooh, wine glass! Right? And then you would look at these and you would say, the one that's activated the most strongly is the one for wine glass, so I'm going to predict a wine glass. Right? Now the hard part about this image and image is you actually have to be able to go into an image and pull out just the parts that are wine glass instead of looking at the image as a whole. It's complicated. I'm just going to leave it at that level. If folks want to know more, we can dig in after. But this is basically what it looks like. These are all those Photoshop filters that somebody's going through, so each square is kind of one of these. Okay, if you guys want to know more, this is actually Nando de Freitas has a really great YouTube learning thing. So I think we're posting slides after. If you want to know, we can definitely send a link for it. Yeah. So last example, I think, is my favorite. So a very kind of visually striking thing is content filtering. So if you want to be able to engage users in a kind of scalable way online, and you want to be able to have your users give you content that you're interacting with, your users don't have a brand, maybe a personal brand, right? But they're one person. They can decide how they want to do that. You probably are responsible for a brand that's bigger than just yourself, and there's some brand identity, and you have to be mindful of that brand identity, right? So there are certain things you may avoid. If you're Disney, you're going to avoid adult content, and you're very strict about this. If you're Calvin Klein and you sell underwear, it might be a little risky, right? Like you might actually actively kind of use a little borderline adult content in order to pull people in for interest, right? So there's a lot of things that you want to consider when you're doing this kind of like you're using user-generated content for other kinds of things. Specifically in the image domain, it's really hard. There's a classic problem of, is this adult content or not, right? Well, you decide. Everybody might have a different decision. But it's clearly a spectrum, and you probably want to be able to say, how adult-like is this content? And maybe you can decide where you want to put your own threshold, right? This is just another kind of API that you can think of, like a machine learning API. You feed it an image, you get back some kind of score for how, not safe for work is this content, right? Yeah. So, I mean, this is actually probably borderline because it's Borat. And you can think about, there's different kind of use cases for this. So, social media is pretty obvious. Somebody posts, an Instagram image that may not be something that you'd want to be displaying in a certain kind of context. If you're Disney, maybe you do it for Calvin Klein, maybe you don't even if you're Calvin Klein, right? E-commerce is actually really interesting. How do you make sure if you're eBay that people aren't posting photos they shouldn't be posting as their product, right? Or if you're Amazon, how do you make sure your third-party sellers are actually posting things that are representative of the category or something like that? If you're web content, you want to take user-submitted stuff, how do you make sure there's not profanity in it? Kind of a problem, but no, yeah. And as well as like, you can see kind of where this is going. Everybody's interacting with users in an automated kind of way. You have to have some kind of filter to make sure that you're only passing on the stuff you want to. This obviously goes off the rails sometimes. So you guys may be aware, a year ago-ish, US Airways had to kind of stop with their Twitter account. They don't do Twitter anymore. So the gist is there was somebody doing something inappropriate with an airplane, and it was clearly out of context of what they thought they were responding to, but they linked a photo they probably didn't mean to link, and it totally blew up, and they had to apologize for this, and there was brand damage, and the end result is it probably got retweeted and favorited more than their regular tweets. You know, way to go, you listeners. And then at the end of all this, they kind of left Twitter. So don't let this happen to you. There's an easy, cheap fix for this.